Today we are going to do some review on graphing quadratics. So it's a good idea to see where these solutions come from, and that's what we did in the part where we had to graph quadratics and see where they cross the x-axis. And so today we're just going to be graphing and then also solving a projectile problem. And I'll also point out what those x-intercepts are and those solutions are. So let's take a look at the first problem. And this one is one where we have to move some terms around. So we always have to set it equal to y when we're trying to graph. So I'm going to end up moving this 8 over to the other side. I'm also going to move this 3x squared over to the other side. And so when I do that, I'm going to rewrite it in a descending order. So y equals negative 3x squared plus 12x and then a minus 8. So from that point, what we're going to end up doing is figuring out our axis of symmetry, which goes negative b over 2a. So our b term is 12, so it's the opposite of that, negative 12 over 2 times negative 3. And so when we do that work, we end up with a negative 12 over negative 6, which just makes 2. So take that 2, put it in for these x's right here, and then figure out what y is. And so what we have is y equals negative 3 times by 2 squared plus 12 times by 2, and then minus 8. So we do some more work there. We've got a y equals, and then we end up with a negative 3 times by 4, and then plus, and then this makes 24 minus 8. So we do some work here, negative 12 plus 24, and I know I'm doing something right when I look at the first two terms, and they are opposite in sign, and one double the other. And that's what I have here. 12 minus 8 makes 4, and so that's where I'm going to start my point of change, which we call the vertex. What it does is it changes directions when we're going along that parabola. And so I'm going to start with going over 2 spaces to the right, up 4 spaces, and then from there I'm going to use what I call the parent graph. So the parent graph, what it does is it gives us lots of points to be able to graph with relatively little work to do. So if we just look at this portion of the equation, this negative 3x squared, that's enough to tell us where points go. This 12x minus 8, all that did is it moved the vertex. It moved the vertex to where it is right now. And so what we'll end up doing is writing down y equals negative 3x squared. Once you get really good at it, you'll be able to do it just with putting points over. Like here, for instance, if I plug in a 1, I square it, I get 1 times my negative 3 makes negative 3. So you could probably do that in your head. Over 1, down 3. And if I go in the x direction 2 spaces, you square that, you get 4. 4 times negative 3 gives us negative 12. So from the vertex, you always have to go from the vertex. So I'll write that down too. From vertex, it has to go from there because we're treating this as like the new origin. We're just looking at this as the graph, and this is where we're starting. So over 2 spaces to the right or to the left, down 12. So that's 4. And then another 8 would be right here. And then another point right here. And let's see if that makes sense. We should have negative 8 as the y-intercept. And yes, it is. Y-intercept's negative 8. So there it is, our parabola. Well, what would the solutions be? Well, the solutions are where it crosses the x-axis. So it's just kind of an approximation. It's in between some points. Looks like it's a little less than 1 over here, a little more than 3. So maybe like 0.5 and 3.5 would be what the solutions would be. Well, this next one, we've got to do a little bit of work. Move this 4x over to the other side. I'll just add it to both sides, and I'll set up my equation. It's a y equals 1/2 x squared and a positive 4x. So from that point, we'll go ahead and use that axis of symmetry formula, negative b over 2a. Substitute those numbers in there. We have the opposite of b, which is negative 4 over 2 times by 1/2. Well, 2 times 1/2 makes 1. So negative 4 over 1 makes negative 4. So that is the axis of symmetry. So from there, you take that negative 4, you plug it in for these x's to figure out where along that y-axis we're going to end up using as the use for the value where it ends up starting. And so we end up going ahead and plugging that in. We have 1/2 times by negative 4 squared plus 4 times by negative 4. And again, we should get this constant thing that happens where we have opposite signs here. So watch for that. 16 times by 1/2. And when I go ahead and multiply 1/2 times by 16, I end up with 8. And then over here I have a negative 16, so minus 16. So I end up with a negative 8. And so that's where I'm going to start. I've got my point at negative 4 and negative 8. And so we go ahead and go 4 spaces to the left, and then down 8 spaces. And that's where we'll start. And so we just use this parent graph. So the parent graph's a little different this time. It's got a 1/2 in front. And so what that means is that we are taking half of the x squared value. So when we go ahead and plug in a number, like let's say you plug in 1, you square it, you take half, that means you only go up 1/2 space. And so over 1 only brings you up 1/2 of a space, not very far. So that's why it's wider. If you go 2, you square it, you get 4. Half of 4 is 2. So over 2 spaces, up 1, 2. And that's it. Well, let's just try another one here. Let's just for kicks go over 4 spaces. Let's square 4. We get 16. Half of 16 is 8. And so over 4, so I'm going over 4. Skip 3, went up 4. See, we end up right at the origin. And that's kind of what we figured, too. The reason is that you don't see a number here. And so if there's no number, that means that 0 was where the origin would, or the y-intercept would end up being. And so if you don't see a number, you can always add 0 to that equation. So there is our graph, and it crosses the x-axis at 0 and negative 8. So those are the two x-intercepts, the two solutions. Well, that's what we're looking at here, is just a situation where we're trying to find out 3 things, and you'll have 2 problems like this. So we've got this water shot straight out of a water soaker toy. The quadratic function is what's listed down below, and we're trying to find out the time it takes this water droplet to hit the ground, and then also basically how long it's in the air for. And then also we want to find out what the maximum height of this water droplet is and how long it took to get there. So basically what's happening is we are starting at 0 and we're shooting up into the air, and then it's going to come back down. So we've got a parabola that is symmetrical, and all parabolas are symmetrical. And what we're trying to find is this vertex to start with. That's going to give us the maximum height right here, max height. And then it's also going to give us the time to maximum height. So right there is the time to max height. And so from that point, we also have this value right here, which is the time in air. So those are the things we're looking for here. And so let's go ahead and try that. So we'll start with this first part by finding the axis of symmetry, negative b over 2a. So we're going to take our b term, which is 32, but take the opposite of that, and it's 2 times by negative 16. So we do that work. Negative 32 over negative 32 just gives me 1. So 1 is the axis of symmetry. Take that 1, substitute it in for these x's to find out what y is. So here it is, y equals, and then we have 1 times by the negative 16, because 1 squared is 1, and then plus 32 times by 1. So we end up with this, just a negative 16 plus 32, which just equals 16. So it goes 16 feet up. That's the maximum height, 16 feet. It took 1 second. Time to maximum height was 1 second. And how long is it in the air for? Well, remember symmetry. It takes 1 second to go up, 1 second to go down. So 2 seconds in the air. So 16 feet, 1 second, and 2 seconds in the air. So those are the types of problems you'll end up seeing on tonight's homework. Good luck.